let's look at this. We are asked to differentiate this. That is, y equals to sine 2x. We're going to use chain rule. Why are we using chain rule? Because working on this direct is a little complex. So what we need to do is to use chain rule. Because if you do the y over the x for sine, let's say sine x, you're going to have cos x. But now we are having 2x. That is the problem. So because of that, we need to perform some magic. So therefore, you agree with me, this is a question 2x. We are going to say let z be equals to 2x. So that we have y equals to sine z. So we can call this one now equation 1. We call this one equation 2. So for equation 2, we are going to do the z. Okay, before that, this is a formula. That is, the y over the x is equals to the y over the z multiplied by the z all over the x. At the end of the day, this equals to this, because if you divide this at this, you are still going to have the y over the x. So what we are going to do now, first of all find this, then we find this, we multiply. What is that? The y over the z. That is the y over the z. So from equation 2 now, we can do the y over the z, which is cos z, because the differentiation of sine is cosine. Now let's go for the z over the s. What is z? That is it. That is, we come here now to say the z over the x is 2x. That is raised to power 1. We move this 1 here. We reduce the 1 by 1. That is 2 multiplied by s raised to power 0, which is 2 times 1 equals to 2. Okay? So here we have 2. So finally, we multiply this and this. That is the y over the x equals to the y over the z multiplied by the z over the x equals to cos z multiplied by 2. Okay, which is 2 cos z. What was z? Z was 2x. So we substitute that in place of z. That is 2 cos 2x, which is finally cos 2x. Hope you understand this. Thank you for viewing.